Hi, everybody. This is Kevin Trainer. Welcome to part one of my tutorial for the coding assignment associated with chapter 14 of the Severance Python for Everybody book. And we're going to be doing this in four parts. There are four deliverables. And this four-part assignment that we're going to be doing is essentially learning how to create custom classes and kind of exploring the various features that we might add to custom classes and how they might help us get our job done. So before we get to the chapter, um, we don't have anything like a custom class in that the um particularly when it comes to holding data values, um, the closest thing that we've come so far is we've been able to create a tuple that we've been using to hold um, kind of data facts from our we were using tuples in chapter 11 from the Zell book. And in fact, I've got some files here that are the starter files for my tutorials, and they're sort of a corollary to the starter files that you're going to get. So back in the work that we did for Zell chapter 11, we had a file that we worked with called river miles data .text. Let's just look at this. It's got in here, um, it's got one line for each of the rivers. These are rivers in the United States and their length in miles. And I forgot where I got this from. Wikipedia, someplace like that. And these aren't all of the rivers in the United States. These are, I think, the top 10, something like that. Okay, and we created a program that we called River Miles Lists. This is back in the exercises that we did for Zell chapter 11. So let's take a look at that code. And we did a lot of interesting things in this program. One of the things that we did is that we read the data from a file, and then we found a way to hold on to the data in one data structure, tuple. Okay, so each from each line of the input file, we constructed a tuple with two fields. And in fact, we do it down in the code here. And the first of the fields has the name of the river. Um, and the second of the fields has the length. Okay. And as tuples are, the fields in tuples are ordered. Okay, they're not named, right? And so we refer to them by an index. Okay, and when we create them, um, we just construct a tuple by taking the fields that we want to make up the tuple, and we surround them in these parens, and those are the Python operators. The parens are the Python operators that create the tuple. Okay? And what we were doing is we were taking these tuples as we created them, and we put them in a list that in my version of the program I called my river miles tuples. And so we created a tuple and we appended it to the list for each of the rivers, the data facts that we got, one data fact per line of the input file. And so when we were finished with the method or the function get river miles tuples, we had a list that had a bunch of tuples in it, each of which was holding one of the data facts. Okay, and it was pretty convenient because of the fact that the tuples held these kind of two-part data facts together in a way that other structures we had dealt with so far really weren't able to do. So we have a really nice kind of a main in this program. We have a function that that gets all the input called get river miles tuples. We do a sort on that list of tuples. That puts it into river name order. And then we had created a function called print report, which it creates a generic report for the list of tuples, and as we keep sorting it, we give names to the function that prints the report that it uses as the report titles. The first one is called river name order. The second one is called length in miles order. Okay, and then that's just the end. So if we run this, okay, if we run this with river miles data text, we get the output that we're looking for, which is to say we get the report in river name order, so you can see it's in alphabetical order by the name of the river, and then we get it in length in miles order. Okay, so that's pretty straightforward, and one of the nicer ones that we've done. In your assignment, instead of working with rivers and their length in miles, you're going to be working with countries and their populations. And so you're going to have the equivalent of the starter files for that data, including the program that listed the countries and their populations. One interesting feature of tuples is when you sort a list of tuples, it sorts them into order by their fields. First field first, then second, then third. And so because the first of the fields we had was the name of the river, when we sorted it, we didn't have to provide any kind of key. Right? That's kind of the natural order for this set of tuples. But when we sorted it the second time, we had to provide a method for the key. The method is called by miles. And all it really does is it gets the miles component of the tuple, which is index 1 or the right one. Okay. Now, this was pretty cool. At least I thought it was cool. I hope that you did too. What it was able to do is it was really able to give us a really lightweight data structure to hold a data record, a multi-field data record. Okay. The drawbacks. Okay, the drawbacks are really two. One is you can't refer to the fields by name. You can only refer to the fields by their index number. And of course, you have to remember what's in each of the fields by their index number. And that's kind of not all the functionality that you like. And the other thing is that um, it's it's all data. It's no real behavior. Okay. We get some behavior from the list when we sort the tuples. Okay. But for the most part, we don't. We can't, for instance, create a method to give us a string representation of the tuple in exactly the way that we would like to do it. There is a string representation of the tuple, and it's kind of good. But again, it doesn't have the names of the fields or any of those kinds of things. So it was a good stopping point. It's a good kind of a quickie way to do things. But we can get more from custom classes. Okay, so let's look at a solution for these data that's based upon custom classes. Now, the first version of the custom classes that I'm going to do is not going to have a corollary in your assignment. It's just kind of an interesting first step. So you might want to just watch this, okay? If you normally follow along, I'll tell you when it might be an appropriate time to begin to follow along. It's not on this particular one. Okay? Okay, so here's what we have. We've created a module to hold our custom class. Okay, and typically this is what's done. Classes are code that are very reusable, and so we can use the same class in several programs. Typically, for instance, we might use it in the program that creates this data file that we had, and then we would use the same class in a file that would in a program that would consume it, like the one that we just saw. And so we don't want to just bind up the class with the program that we're writing. We would rather package it up in importable module. So we called the module My Barebones Rivers, and it's a module that contains the river class and the related code. Now, the related code here, for the most part, is just the unit testing code. Okay, and that's a pretty good place to put your unit test. If you adopt one of the formal unit testing frameworks, you're probably going to put your unit tests in a separate class. Okay, you probably won't include them in the main function of your module file. But the style of coding that we've been using for the unit test will serve you well when you learn how to use one of the unit testing frameworks, because they're all based on the principles that we've been using of testing it test case by test case, naming the test cases so you can understand what you're testing, explicitly predicting what you expect the outcome to be, and then reporting whether you really got that outcome or not as either a passed or a failed. Okay, and that's pretty much how all the unit testing frameworks work. The only thing that we're not doing is we're not really using the kind of automation engine that come with formal unit testing frameworks, which, I wouldn't say it's a class in itself, but it certainly a learning unit in itself. Okay, so uh, let's look at our class. So the amount of code that you have to put into a class that it can hold one of these river name and length facts is really small. Okay, so if you want to have a bare bones class, really the highlighted code that I'm showing you here is all you need. Okay, what does that code do? Well, it declares a class, it gives it a name. Classes have names that, as we know from the lecture, uh, it begin with a capital letter and use camel case syntax. Um, these are the one set of names that are kind of formed in a different way than the rest of the Python identifiers are. In this, the way that we form class names here is reminiscent of the way they do it in other object-oriented languages like Java. Okay, we've got two instance variables. Okay, and we talked about those in the lecture. Instance variables are fields that we'll have one copy of for each of the instances of the class that we construct or instantiate. Okay, and as you can see, each river has a name and a length, and we've decided that we're going to give them default values so that when we construct a river object, it is, upon construction, it's going to have a name that's the empty string and a length that's equal to 0. Okay? You may be used to custom classes from the lecture that have a constructor that allow you to pass in initial values. But the bare bones version hasn't got that. Okay? So you construct essentially a blank object, and then when you want to populate it, you simply set the values on that object. Okay, and it's not as convenient as it might be, but this is about as simple as one of these classes to hold data values can get. Apart from the testing code, it's really only 3 lines long. That's pretty simple. Okay. Okay. Well, how could we test that to make sure that it would work for us? Well, let's see. The first thing we need to do is we need to be able to construct one. And you might say to Kevin, well, I thought you said we weren't going to have a constructor. Well, if you don't provide an explicit constructor, okay, you still construct objects. And when you create them, you still call a constructor name. It's just an implicit constructor. So what would the implicit constructor for river look like? Well, it would have the name that we see down here on line 19, river paren. So if you don't provide an explicit constructor for classes as you define them, there's an implicit one that exists that assumes that you're not going to pass in any initial values. If you try to pass in initial values, you'll get an error. Okay, so let's look at unit test 1. And again, these unit tests are pretty much using the format we've used all along. Okay, so I'm going to take the unit test that I already have, and I'm going to just run the first one. So it's test 1, and I call this the same thing in a number of these object-oriented programming languages. The best way to describe this is it's an implicit no argument constructor. You don't pass in any parameters or arguments. Okay? So here's what we do. We expect the name to be set to the empty string. We expect the length to be set to 0. We construct a river object, an empty one. That's the only thing we can do with the version of the class that we have here. We hold the reference in the variable r1. Then we get the actual value from the class. And what we do is we just use the field name. Okay, so we say actual name equals r1 dot field name. Okay, and actual length equals r1 dot length. So and so then we have the actual name and the actual length, expected name and expected length, and we compare those. If either of those are not equal, we print failed. If either or not, if they are equal, we print passed. And we've used a trick here that I've not really emphasized a lot, but it's a good programming trick. Typically, if you have a variable that you name in all caps, that's a signal that it's used as a constant, which means that we don't change the value, which means we can kind of freely pass it around because code is not supposed to change it. And so you don't really have to worry about what any particular code is doing with it. And then we typically declare these up in the top of the module, whatever kind of module we have. So here we have a kind of object-oriented one, but it'd go kind of in the same place if we use this approach in a more procedural kind of Python program. Okay, in that case, if it was a procedural program that did not have a class, it would just be inside the module, it'd be inside the file, but it wouldn't be inside any of the functions. Okay. Here it's inside the module, it's not inside the function main, and it's not inside the class river. So this allows us to not have to code these literals for failed and passed in a redundant way throughout the program. We can just use these constants. Now, if you read up, you'll find that Python really doesn't have constants, which is to say, if we want to assign a value to failed, okay, we could. So we could change it to, instead of the string failed that we have up here, it could say hi Kevin or goodbye Mary or whatever. So there's nothing about the Python infrastructure that keeps you from changing values that you name in these kind of all caps. If you have multiple words, you separate them by underscores. But it's a coding convention. It's your way of telling the reader of your code, oh, this is something I'm going to treat like a constant, even though Python doesn't have official constants. So you can expect that I'm not going to be, once I give it an initial value, typically in the top of the program, I'm not going to be changing that value. So these are constants in not some kind of a Python infrastructure sense. These are constants in sort of a Python programmer intentional sense. Okay, so let's run this test. So we run it, and if you look at the output, we passed. Okay, So when we constructed a river object that we called R1, um, it had the expected default values in it, and we tested that, and we were able to see that it did. Okay. Now, again, with a bare bones class like this, we don't have an explicit convenience constructor where we can pass in the values. Okay. And we'll do that as we go on to the work we're actually going to hand in. All right. Okay. Well, then we can construct a blank one, right? What's the next things we'd like to do? Well, I think we'd like to know that we can set the value in each of the fields. Okay, so how do we do that? Well, here's our second test. So I'm going to uncomment that. Okay, and test setting the name field or attribute. So the expected name that we want to have at the end of all this is Nile, the Nile River. We construct a blank river object R1. We just assign the value of expected name to R1. Okay. Um, uh, we we get we retrieve the value of the name field or attribute from the R1 object. We put that into actual name, and then we compare them, and we're going to expect them to agree because the name, after we set the name, it should be Nile and not the empty string. Okay, so let's run the unit test. And test 2, test setting name, passed. So here's something that I want to show. At this point, we've been able to get the value from the object. We've been able to set the value of the object. And you'll notice that we haven't used any getters and setters. Okay, we haven't had to create a method up here called get name, set name, get length, set length, and that's really because in Python, unless you have some special considerations, the typical style is that we don't use explicit getters and setters. Now, in other object-oriented languages like Java and C++, the general kind of conservative approach is that you create a getter and setter for every field, and you have this concept that we call encapsulation, which is we say that we don't access the values of the fields directly. Well, if you looked at what we did in the Severance chapter, we did access some of the fields directly, and also in some cases we used a getter. Okay, well, that's not really the Python way. Okay, I mean that's most of us who have come to Python have been converted from other languages, particularly Java. And so that's using getters and setters is the Java way. It's not the Python way. So when you're using the very bare bones version of the class, you don't call getters and setters. You don't have methods that have those names. You just access the fields, both on input and output. And that's what we did here. Here's what we say. I'm sorry. Where did we set the name? Yeah, it's right down here. So how did we set the name? We just set the name right here. How did we get the name? We got the name right here. Did we call methods that we had to define that are getters and setters? No, it's pretty much not the Python way. Okay, so when you start out with Python, unless you have a need for getters and setters, you start out like this. Okay, just accessing the fields. All right, and now we have another test. We just want to be able to prove that we can access the length field. Okay, and we're just doing kind of the corollary with that. Okay, so let's run that test. See if we pass that test 3, and we're passing test 3. Okay, and so it's really it doesn't have a lot of behavior. Okay, you can construct a blank one. You can get and set values from of instances using just accessing the fields by name as fields and not having to call getters and setters. Okay, and you'll notice that we haven't included any code here to create a version of how do I want to create a convenient string representation of the object. When we ran the program that used the tuples, when we tried to get a string representation of the object, we got one. Okay, it's not that hard to do. Okay, it wasn't particularly pretty. Now, what happens here? What happens if we just let's do something like this. Let's act like we have another test. It's not really a test. Well, I guess it could be a test. We just want to demonstrate what kind of code, what does it look like? We're going to say display string value of object. So we've created an expected length of 1500. Okay, and let's give it an expected name of the Amazon River. Okay, we construct the object. We set the length. Okay, and then let's oh, I'm sorry, we got the length from that. I did not set the length. I'm sorry. I'm going to back up a bit. We failed at test 2. So let me let me go back and this is my test 2. Let me go back and get test 2 to work. A lot of the times when you're using these formal testing frameworks, when you run a test, you get a green bar if everything passes. So it's kind of hard just to see what you want to see. If you see red, you know you have a failure. If you see green, you know you have all passes. Now here, even though we've made it very easy to see that we failed, I missed it. Okay, so it shows you have to be careful. Now, why wasn't the actual length equal to the expected length? Well, we never set the length. Okay, so we never said r1 dot length, r1 dot length, set the value to the expected length. We never said that. Now, did we? No, we didn't. All right, let's see if we can pass test 2. Yeah, okay. So, I'm sorry. We call them both 2. I'm working on Thanksgiving here, okay? And that's my excuse for being distracted. I apologize. This is test 3, and we want it to pass. So let's run it. Okay. So we passed uh, constructing a blank object, setting the name, setting the length. Okay. Now, let's copy that one where we've got some setting going on. Okay. And let's say that we're going to call this test 4. Okay. Which is what it should really be called. Okay. And let's call it display string value of object. Okay, so let's see. Let's give it an expected length. Let's give it an expected name. Let's say it's Amazon. Construct the river. So we set the length, and we're going to set the name. So we're going to say r1.name equals expected name. Okay, and again, we're not calling any getters and setters. Excuse me. We're just doing that. And then let's get rid of this part on the end. And let's just look at what happens if we say that we want to print a string representation of R1. What does it look like? Does it look like anything useful? And I'm going to tell you that it's not. Okay? All right. I've got a problem here that I've got to fix. So let me fix this problem and I'll be right back. Well, I found this problem, and it's pretty subtle. Line number 47 here is not indented as far as it should be. That's all the problem was. Okay, so it confused the syntax checker. Okay, so let's give this a run. And I just want to show at this, when we have this bare bones version of the object that doesn't implement the dunder str method, which gives you a string representation of the object, you get really ugly values. Okay, so it says we have a river object that belongs to the main function, and it's at a certain memory address. You don't know what the contents are. It's not really that helpful. Okay? All right. I'm just going to put that back into comments again. And again, I'm going to run this. I'm going to say, okay, well, I'm not going to try using that if I have the bare bones version. Okay, so let's review this again. In the bare bones version, all you have to do is to declare a class, okay, and then to declare inside the class, not inside any kind of a method, each of the fields that are going to be the instance variables for the class, and assign them some initial value that will represent a blank version of this object. Typically, these things are the empty string, for values that are numbers, they're typically 0. For booleans, we typically make them false. Okay, those are typically is the kind of blank state of a new object. Okay, now what's the hardship in using this bare bones version? Well, what's the upside? Really fast. We can knock this out very, very fast. So if we very quickly we're trying to evolve a solution, and we go, well, I want to put together a custom class to hold these kind of objects. Bing, 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 you can have one in a jiffy. Okay. What are the drawbacks? Well, the one that I think is the most troublesome is that we don't have a formal explicit constructor that allows us to construct fully initialized instances of the river object here in the way that we like to do, which is to call the constructor with all the initial values and to get back a fully initialized object. Okay, and then the other thing is we haven't added the code to provide a string representation. So if in our testing we want to display the object and see what the values are for the object, we're going to get a really useless version of that display. Okay, so again, I've been telling you all along that just to watch and not to follow along. Now, if you're somebody who follows along on these and does the code, now we're going to do the program that is the equivalent of the first one that you're going to do. So let me bring that over. Okay, it's called My Basic Rivers. Okay, so let me copy it in and we'll take a look at it and we'll walk our way through it. Okay, all right, so what does it have? Okay, well we have those constants up here we use for passed and failed. Okay, we've got the unit tests that we've had. We have a little bit different unit test because we have an explicit constructor now. We still want to make sure that we're able to set the name and the length, right? And we've added a dunder stir method that creates a string representation, and we want to test that too. So where's the code that actually does the work? Well, you might say, Kevin, where do you declare the instance variables? Don't you want to do something like this? Don't you want to have code that we had before? Don't you want to say name equals the empty string, and then, well, we don't want to do that last operation, and length equals 0. And I'm going to say that you could do it. Most experienced Python programmers, as soon as they have a constructor, this dunder init is the constructor. As soon as they have that, these lines in it that set self.name and self.length to the values that we're passing in, these are adequate to create an instance of variable called name and length. And so these, with 2 lines up here that we currently have on 9 and 10, are really redundant now. Okay, so most experienced Python programmers just get rid of them. So how do you tell what the instance variables are for a class that has a constructor? Well, you look at the fields that we create in the constructor. Okay, and every instance variable begins with self dot. So we have a self dot name, and we give it a value. We have a self dot length, and we give it a value. Okay, so this is how you evolve from the very bare bones, which you typically won't do. This basic version is not too much more work than the bare bones version, and more friendly to be able to use them in a couple of quick programs. So I wanted you to see the bare bones because I wanted you to know that you really could create something that lightweight and feature empty. But this basic version is where your average Python programmer is going to start, right? So eventually we're going to evolve one level further. Okay, so this is the basic version. The next version that we're going to do, I used to call sophisticated, but it's not really sophisticated. It's just evolved. These classes evolve as your requirements get more complex. Okay, so the reason why we're not really thinking of this as an evolution from the bare bones version, one, it is an evolution from the bare bones version, but people don't usually go that bare bones. This is where they typically start. Okay, so what do we have? Well, we have a constructor. Its name is dunder init. Okay, it has the self formal parameter. We're passing in a name and a length. Okay, and its whole job is to initialize the instance variables. So the name one is referred to within one of the methods. When you refer to this, it's always self dot. So the instance variable name is self dot name, and the instance variable length is self dot length. Okay, so we've got that. All right. What do we do here in the dunderStir method? Well, dunderStir is, again, a standard method name. Again, it's part of the infrastructure, so we don't typically call it explicitly. Okay. And what we're doing is we're building a string, and we're using a pattern that I think we practice at least once in our course, where instead of using a string in which we keep trying to concatenate things on the end of the string and creating a new string object every time, what we do is we build up a message as a list of strings, and then we join them at the end using the space as the join character, and the result is that we get a pretty string. Okay, that includes the name of the class, the name of each field, and the value. Okay, now when we create the value for the name, we can just refer to it, because we're inside of a method, we can refer to it as self.name. Okay, when we create the string value for the length, we can't simply refer to it as self.length, which is an int value. So we have to explicitly ask for it to be converted to a string, because we're going to concatenate this right square bracket. Okay, so let's look at the let's do some testing. Okay. Uh, the first thing I want to do, this is code we haven't seen before. Let's see what the string method looks like. Okay, so let's cover up all the unit tests. Okay, and let's construct a river one equals gets assigned river Amazon 2100. Okay, and then let's say print a string value of R1. Okay. All right, let's see what that looks like. That should be the only thing that's really going to execute. And look at that, it comes out really nice. So we get the object type, river, and then each of the fields is in square brackets. And it says the name field is equal to Amazon, the length is equal to 2100. Now this is a format that I borrowed from a tool that I used to use in Java that used to build these things for you automatically, and it used to use this kind of format, probably still does. And I just happen to like that format, so I borrowed it. Okay, so that's what we're going to get, right? All right, that looks good. All right, so let's get into the proper test. We have a test of the toString down in the bottom. So the first thing we want to test is this explicit constructor that gives us the convenience of constructing a river with a name and a length. And again, the way that we typically do this is we set the expected name into a variable expected name, the length into a similar variable. We call the constructor with those two fields. We fetch the name and the length into the actual name and the length. We don't have to call an explicit getter. We just access the fields. This is a Python way to do it. Okay, very nice. And then we say if the expecteds don't equal the actuals, then print failed. Otherwise, print passed. Okay, so let's see what happens there when we go to test that. So our first real test is called test a constructor, and we passed it. Pretty nice. Okay, now what's the next thing we have to test? Well, after we construct the object, what if the name should change? What if we're writing a program that uses this class and we display this to the user and we ask them if they want to change the name and they say yes, and we ask them for the new name? Well, then how can we set the name in a of an already constructed river object? Well, you know what we would do? We would set the name. I guess we could have done this in a little bit different way, but we set the name. The object is in R1, so R1 dot name is equal to Amazon. That shifts the expectation that we're going to get from Nile to Amazon. Okay, and then we do the comparison. So can we reset the name to Amazon, and then have a comparison where it's equal to Amazon and not its original constructed value of Nile. Okay, let's look. That's test 2. Let's give it a run. And test 1 and 2 have both passed. Okay, so what's the next thing we want to do? Well, we want to do the same thing for length. Okay, we just want to be able to construct an object that has a certain length, and then we want to set it to a different value just to show that we can. So we construct a river with the values Nile 2000. Okay, we construct it into R1, and then we set the length of R1 to 3000. We change the expectation that we're going to get to 3000. We retrieve the actual name and the actual length just by accessing the fields, and then we compare. Okay, and so if they're not equal, we're going to print failed. Otherwise, we're going to print passed. Okay, let's run this. And test 3 has also passed. Okay, we're not too surprised. We saw that before we were able to set it, and having an explicit constructor doesn't make that hard to do. Okay, so how are we gonna test the toString? Well, here's what you want to do. Okay, you want to construct an object, and then you want to try to retrieve the value of the object as a string, which you can do with the code here. Okay, so we can say the actual string value gets assigned. We call the stir function on R1, and that implicitly calls our dunder stir method. Okay, so now we just have to know how to compare an expected string value to the actual. Well, you could go through all kinds of, you could write code in here to build the string from the parts and all this kind of stuff. Here's what I usually do. Okay, I usually do this. I usually build the first part of the test. Okay, and then I create a kind of a chatty test you have to visually inspect. So I just say print string value of R1. That's all I say. All right. Good. All right. So now I run the test again. And it goes, and then I visually inspect it. I go, okay, names equal Nile, that's what I wanted. Lengths equal 2000, that's good. Okay, and so now what I do is I just essentially cheat. I just take the character string that I printed out, and I copy it, and I put it back into the test code. Okay, so over here, when I have the expected string value, I just take whatever printed out, which I've already visually inspected, right, and I paste it into here. Okay. All right, now we don't want to print the string value anymore. We want to retrieve it with actual string value equals stir of R1. Okay, and then we want to compare them. So now when I compare these, they pass. And so a lot of people, when I show them this kind of cheater trick, will say, well, Kevin, you cheated. You printed it out, and then you decided that was the right answer, and you copied that into your test. And I said, yeah, but I only did that after I inspected it. So I actually did a visual inspection test on the first version of test 4. And then I copied that. And now I've got a test value in there that I'm going to expect to work. Now, how does that help? Well, later on, if you change the class and say you add another field, okay, um, then you might change the code in the dunderstir method, okay. So you might add on the third field, okay. But on the other hand, unless you come down here and you maintain the test, now it's not going to match. Okay, so this does a good job of reminding you in any version as this evolves over time, it tests um, it tests the version that you had before. And if you don't go changing things, um, you're going to have to come back in here and again, you're going to have to fudge the test to find out what the value is. And when you do that, you're going to visually inspect it. Okay, so now we've got a version. We've got this basic version of the river class. It's fully unit tested. Okay, it's got more functionality than that original barebones, which I showed you not as a recommendation, but as a demonstration, right? So the basic version is, I think, pretty good. Okay, this is where people start with classes. When they use the class, they're not using any special getter or setter code. Typically, when you begin, you just want to model things like this. Okay, if you have some further requirements for the class, you usually make that the next version that you do, and that's what we're going to do in this assignment. There's going to be a further version called the evolved version that is going to evolve from this. But before we get that to work, we're going to go on to part two. Okay, and we're going to do the testing. Now, where are you in your work? Well, either you followed the work that we just did or you didn't. Okay, if you follow the work that we just did and you have code, well, you can probably clone that code into the code needed for exercise one of your assignment. So here we created a river class in your the exercise you're going to hand in. You're going to create a country class that's going to that is going to hold country population facts. Okay, and again, you're going to create the basic version of it that's going to look a lot like the code we have here. So that's what you're going to do, and then I'll see you in part two, where we're going to create a client class, the new version of River Miles list that is going to use this class-based version in order to print a pretty report. Okay, so that's it for one. I'll see you in two. Have fun with exercise one.